Hi, in this tutorial I would like to take a quick look at the openGl function library introduced inside of Mari Extension Pack 5. The openGl function library is a series of nodes designed to do visual coding inside of the Mari Nodegraph. Each node corresponds to an openGl function, so if you're familiar with a bit of coding, you should be able to code up some small nodes yourself and make them available to your team. The function nodes can be found under the Nodes Math section, Extension Pack, and in here we have a whole series of nodes. Function nodes are prefixed with gl_. So here, for example, I have a gl pi node which outputs the pi value. Subsequently, if I do, for example, a gl smooth step, I will get the openGl smooth step function. The names of the new function nodes correspond to the real function names of openGl, so you should be able to find the functions online quite easily. You can also have a look inside of the node information to see what the node might do. Let's take a look at coding up a little example. I have a house here and I have baked an ID map, so each shape has its unique color. What I want to do now is have an axis projection that has a unique offset per shape. I'm going to create my axis projection. I'm going to use one of the extension pack grunges that ship with it and just project the grunge on there. Now you can see the grunge flows over each shape, so there's no seam between shapes, which might be desirable, but in my case I want to have a unique offset per shape. So for example, this window ledge should have a different grunge look than the wall next to it. The first thing we need is a random function. So we have the GL random range, for example, which has a min and a max value and a seed. So it outputs a random value between the min and the max based on the seed. I'm going to use my ID map and create a radio transmitter, so I can use that ID map down here, and then just create a radio node. Use the luminosity. I'm going to hook up the radio node to the radio transmitter and connect it to the seed. Now let's just create the min and max values. So I'm going to create a float node and a second float node and hook these up to the min and max. And the result I'm going to pipe into the UV offset of the axis projection. Let's view the axis projection again. Nothing has changed because the max value is still at 0. So I'm just going to increase this. And now I have already a unique offset per shape based on my ID map. Now let's bundle this up into a little node. I'm going to select all my nodes and I'm going to create a group. And let's name this random projection offset. I'm going to control double click onto the group to go into the subgraph. Name my input. So now my input is named ID map. I'm gonna name the min and max values offset. So when I expose values, they get grouped under a group offset. And now let's just expose the world scale and the image to the outside of the group, and also the min value as well as the max value. So now if I click on my group node, I have all these values nicely exposed and can tweak them without having to go into the graph itself. Let's quickly rename our min and max so they're nicely named attributes. And now we can export this node as a gizmo and place it into our Documents Mari Gizmos folder. And whenever I restart Mari, I will have this node available as a new node. So you can see here the random projection offset is available as a new node. However, this only happens once you restart Mari. But this way, as a TD for example, you can quickly code up little nodes and share them with your team.